In this video clip, we are going to look at how to change the standard form of the quadratic function into the vertex form, which is in this way. First, let's see how we are going to change the form. And the following is the proof. So we want to understand this whole process. Well, step 1 from row 1 to row 2 is you leave C alone without doing anything, but you pull A out. So then you have 2 terms inside the brackets like this. Why? Because if you distribute A to x squared, you get ax squared. If you distribute A to the second term, you cancel A with the downstairs A, so you have a bx right here. So it goes back. So step 1 from row 1 to row 2 is easy. And then step 2 is from row 2 goes to row 3. Okay. In this case, again, we leave C alone. Okay. What we did was add b squared over 4a, and then we subtract the same quantity. Those two will be cancelled anyway. So row 3 and row 2, row 3 are the same. It's basically we add and subtract the same term. Okay, but why is b squared over 4a squared? Not other thing. Okay, here is the reason. We first is notice that x has coefficient b over a. X has coefficient b over a. We choose half of it, and then we square it. And then square goes to everywhere. This will give us b squared over 4a squared. 1 squared is 1. Times b squared is still b squared. Now we got b squared over 4a squared. That's how we got that. And then we did not do anything with the first 3 quantities. We leave it alone. We just get this term out of the brackets. And again, we leave C alone. That would be our third step. You see, this A was outside. When this A times negative b squared over 4a squared, then you have a negative b squared over 4a without squared. Because 1a upstairs and a squared downstairs, you will cancel 1a. So this will be negative b squared over 4a, which is this term. So step 3 is just take this quantity out of the brackets. Okay. And then step 4 is from here to here. From row 4, this one, to this one, row 5. Okay. Basically, it tells us that the 3 terms inside quantity, inside the bracket, gives us a complete square. Why so? Look, complete square x plus b over 2a squared is actually x plus b over 2a times itself. Okay, then you know that will be what? Will be, for your method, x times x is x squared. Outer product is x times what? B over 2a. That will be b over 2ax. Inner product is the same, b over 2a times x, so you double that. Okay, then finally is b times b, b squared. 2a times 2a is 4a squared. So then you see you cancel this a with this a, that's b over ax. That's the middle term. The last term is the one right here. And then the first one is x squared. So inside the brackets gives us a complete square. And again, from here to here, we did not do anything. We just put c at the front because it's positive. And then b squared over 4a is negative, so we put it behind. This will give us the vertex form. What is vertex form used for? If we let x equals negative b over 2a, what do we get? We get will be a times negative b over 2a plus b over 2a squared. This is going to be 0. They cancel each other. And then we copy this one as c minus b squared over 4a. Because a times 0 squared is still 0. This one is 0. And then the value we get is c minus b squared over 4a. Okay. You know, this quantity is all the time positive because of squared right here. Okay. So this one is positive. If a is positive, then you get the whole term will be positive. Okay, so if we will have a negative b over 2a for x, x choose this value, then you will make the no negative number be 0. The whole quantity is going to be 0. This quantity. Of course, that will be the smallest because all the time is positive unless x is this value. Then it reaches 0, the smallest. Then this one quantity is the smallest. This one will be the smallest. So that's why we say when a is greater than 0, and then if x equals negative b over 2a, we will get minimum value, c minus b squared over 4a is minimal. Because open direction was like this. This will be the minimum point with x value equals that, and the y value equals that, this point. Okay, when x is less than 0, the open direction will be downward. So the vertex is right here. X value is again is this value. Y value again is the same value here, which will be maximum. Let's look at an example to illustrate the application of this vertex form. Here is the example. Let me show you right here. Show you right here. You see, by the formula, we shall have a what? We shall have a negative b without a square. Let me get this square out. Okay. Erase that part. So 1x equals negative b over 2a. X equals this value. Put here, you're going to cancel that. So basically, we need to find out this x coordinate. We know here is A, here is B, here is C. So A is 2, B is negative 6, C is 4. Okay. By the value right here, you want to calculate negative B over 2A. Negative is always here, and B is negative value, negative 6, divided by 2 times A. So you have a negative will be positive for x. So 1x equals this value, comes from here, is actually in the equation, you will have this value, which is 3 over 2. Since a is greater than 0, then at x equals 3/2, the function will reach the minimum value, negative 1/2, by calculating c minus b squared over 4a. Okay, c again is 4 from here and here. Minus b squared is negative 6 squared divided by 4 times a. 4a is 2, so 4 times 2. Okay, you can calculate that as 4 minus 36, negative 6 squared, divided by 2 times 4 times 2. 4 times 2. You can see that will be 4 minus 9 over 2. Okay. Then it's going to be what? 4 is 8 divided by 2 minus 9 over 2, which gives us negative 1/2. 8 minus 9 is negative 1. So we got that. This will be the minimum value, negative 1/2. Okay. If you look at the graph, if you look at the graph of function, that will look like this. What you want to do is click this one. You'll get this graph. Okay. So you see 1x equals 3/2. That's 1.5 between 1 and 2. And the c is negative 1/2 is negative 0.5. It's right here. The graph looks like this. And this point is actually called vertex. So at this point, a is 2. Open direction is up. 1x equals 3/2. Your y value is negative 1/2 or negative 0.5. Okay? So please review this lecture. I'll see you next time.